Hi students. Next we see the exercise number 3.2. Question number 2. Find the LCM of the polynomial. Find the LCM of the polynomial. Let's see the fourth Roman number. See p square minus 3p plus 2 and then p square minus 4. First of all, we want to find the least common multiple. Means we have to take all the terms with the highest values, highest power of the terms. So here we are going to find the LCM solution. Let me take the Roman number 4. The Roman number 4 is given as p square minus 3p plus 2. It is a quadratic polynomial, right? So we can easily factorize the term. If you factorize, if you multiple, we need 10. If you add, we need, multiple, we need 2. If you add, we need minus 3. What are the factors of 2 means? 2 ones are 2. And here we have made the minus symbol. So both the term has minus. So minus into minus plus, 2 ones are 2. And then if you add this two terms, we get minus 3. So that is the exact factors. Then the factors are p minus 2 and p minus 1 are the factors, right? Next we get the second polynomial, that is p square minus 4 is given. See, the 4 can be written in the form of p square minus 2 square. Perfect square number, right? So 2 square. So it is in the form of a square minus b square. So we apply the formula, that is a square minus b square means a plus b and a minus b is the formula. Now here we can take that then a is equal to, in the place of a is equal to b, in the place of b is equal to 2. Now apply in the place of p plus 2 and the p minus 2 is the formula. P plus 2 is the one of the term and the p minus 2 is the another term. Now we want to find the LCM. LCM means we have read all the terms, right? The LCM is we have read all the terms. So here we have p minus 2, here we have p minus 1, here we have p plus 2, and p minus 2 is already read. So let it, and then all the terms add to the power 1 itself. So this is the LCM of the given polynomial. Next we see the fifth Roman number. Fifth Roman number is given as 2x square minus 5x minus 3 is the one of the polynomial, and then second polynomial is 4x square minus 36 is the another polynomial. Now I take the fifth Roman number. Here we have 2x square 5x minus 3 equal to 0. Here it is also a quadratic polynomial. So easily we can find out the terms by factorization. See, the coefficient of x square as the variable, the coefficient of x square is 2. So the 2 should be multiple with 3. So minus 3 to factorize. 2 into minus 3 is 6. Right? If you multiple, we need 6. If you add, we need minus 5. Then what are the factors of 6 means? We have the factors 6 ones are, 1 6 are, 2 3s are, 3 2s are. These are the two factors, right? So here we need the term. When we multiple, we need minus 6. When we add, we need minus 5 means 6 ones are 6. See, here we have minus, so put minus symbol here. So minus into plus minus, 6 ones are 6. If you subtract this term, we get minus 5 as the term. Now, what number we have multiple divided by the same number? We get 3 here, minus 3 is the one of the term, and then 1 by 2. So then the factors are x minus 3 is the one of the term. See here 1 by 2, the 2 should be, the denominator 2 should be taken to the coefficient of x, that is 2x plus 1. That is the factors, right? And then next up, 4x square minus 36 is given. 4x square minus 36 is equal to, see, the 4 is a perfect square number and 36 also a perfect square number. Let me rearrange this as in the form of 2x whole square. If you square this term, 2 square is 4, x square is x square, right? 4x square. And then 6 can be, 36 can be written in the form of 6 square. Now, the given term is in the form of formula a square minus b square term. So, here we have a square minus b square means we have a formula a plus b and a minus b. By the given condition, here the place of a is equal to 2x, in the place of b is equal to 6. So 2x plus 6, 2x minus 6 are the two terms. So 2x plus 6 and then 2x minus 6 are the two terms. A square minus b square, a plus b and a minus b. So the LCM of this term is equal to, the LCM is, we have made all the terms, right? So here we can take 2 as commonly outside in both the term. 2 as b, take it as commonly, or otherwise take it as it is. X minus 3 is the one of the term and 2x plus 1 is the another term. And then here 2x plus 6 and then 2x minus 6 is the LCM. Or here we are going to take the x term as commonly outside means, then we have that here we have to take the common units. 2 into 2 is 4, then x minus 3 and then 2x plus 1. Here we have x plus 3. Here we have x minus 3. X minus 3 is already we have taken. So let the term as this is one of the LCM is let it here, or otherwise we can take this also as a LCM. Next we go to the problem number 6. Problem number 6 is given as 2x square minus 3xy whole square and then 4x minus xy whole cube and then 8x cube minus 27y cube is given. Right? I clear this to read the next question. Sixth Roman number. The given term is 2x square minus 3xy whole square. Let me check it one by one. Now, see in both the term, x is the common term, so I take x as the outside. See here, x into 2x minus 3y whole square. See, in this term, inside x I take out commonly, so whole square will be there. If you square the term, we get x square into 2x minus 3y whole square. Here, x will be the common term. X is taken from inside the term. We have whole power, so whole power will be taken as outside. So x into 2x minus 3y. So square we get x square will be 2x minus 3y whole square. Get it? And then the second one is 4x minus 6y whole cube. See here the multiple of 2, right? So in this term I am going to take the 2 as outside. Inside the bracket 2 is taken out, right? So 2 if we take commonly outside we have 2x minus 3y whole cube, right? Inside the bracket we are taking the 2 as commonly outside, so we have 2x minus 3y whole cube. Now cubing the term we get 2 cube into 2x minus 3y whole cube. 2 cube is nothing but 8, 2x minus 3y whole cube. And the last term is given as 8x cube minus 27y cube. See, it is in the form of a cube minus b cube form. So we have to rearrange in the terms as 8 can be written in the form of 2x whole cube. If you cube this term, 2 cube is nothing but 8x cube. So the term. And then minus 3y whole cube. 3 cube means 3 is 9, 8 is 27. 27 into y cube. So we get the same term. Now compare this form with the formula a cube minus b cube. It is in the form of clearly a cube minus b cube. So we have the form a minus b into a square plus ab plus b square. So a cube minus b cube formula is a minus b into a square plus ab plus b square. So in the place of a is equal to, here we have 2x. In the place of b is equal to 3y. Now substitute a and b in that places. So we get the value as 2x minus 3y and then here a square means 2x whole square plus a into b. So a is 2x, b into 3y and then plus b square is equal to 3y whole square. Now square the term and write the term 2x minus 3 If you square, we get 4x square, 2 square is 4, and then x square, plus 2 3 is 6, xy, plus 3 square is 9, y square. Now we want to make the LCM of this term. Therefore, the LCM is, first we have to make all the terms, right? So, see the first term, here we have x square into 2x minus 3y. Power should not be here now. First, next term, here we have 8. And 2x minus 3 is already have entered. So, let it, here we have 2x minus 3y, sorry, 2x 3y. Here we have 3y, 2x minus 3y. So, let it, the remaining term is 4. X square plus 6xy plus 9y square. So we have to arrange the term. Before we are going to arrange that, see the highest power of 2x minus 3y. Here we have square, here we have cube, here we have only one term. So we take the highest power of the term as the LCM. So then the LCM is equal to 8x square. We have to rearrange the terms. 8x square into 2x minus 3y whole cube into 4x square plus 6xy plus 9y square is the LCM of the given term for the sixth Roman number. Thank you, students. Class 10 algebra. Exercise number 3.3, question number 2. Find LCM of the each pair of the following polynomial. Right? Find LCM of each pair of the polynomial. Here the two polynomial is given. Whose GCD is also given. Whose GCD is a minus 2, right? Now, let me take this. The first polynomial as f of x or p of x, whatever be. Here I am going to take it. Let f of x is equal to, right? A square plus 4a minus 12. And then, second polynomial take it as g of x. G of x is equal to a square minus 5a plus 6. And then whose GCD is given as a minus 2, we want to find out LCM. To find the LCM, here we have the formula, right? The LCM into GCD of this polynomial is equal to product of the polynomial, product of f of x and g of x. LCM, the product of LCM and the GCD of the same polynomial. Here LCM is mentioned the this two polynomial only. GCD is also this two polynomial GCD only, right? So the product of LCM and GCD is equal to the product of the polynomial f of x and g of x. Here f of x is given and g of x is given and GCD is given. We want to find only LCM. So if you divide the given polynomial by GCD, we get the LCM, right? So LCM is equal to f of x into g of x divided by GCD. That is the format. Now, here the f of x is equal to, the f of x is given as a square plus 4a minus 12. By factorization it is, first we write the one of the step, a square plus 4a minus 12. And then g of x is equal to a square minus 5a plus 6 divided by the GCD is a minus 2. Now factorize this term. If you factorize, when you multiple we need minus 12, when we add we need 4 for the first one. See, what are the possibilities here? You get the term means factors of 12s are 1 12s are 3 4s are 6 2s are, these are the factors. Here 6 2s are is suitable. See, when we multiple we need 12 and here we have plus value, so put highest value as plus and then small one as minus. Plus into minus, minus 2 6 are 12. If you add these two, 6 minus 2 is very equal 4. Then the factors are a plus 6 and then a minus 2. Now factor this one. Second one is the quadratic polynomial, right? So when we multiply we get 6, when we add we get 5. The factors of 6 are 1 6 are 2 3s are 6. So here I choose the term 2 3s are is suitable to the here because we have the negative symbol in the addition. So minus minus, both are in the negative symbol. Minus into minus plus, 2 3s are 6. If you add this term, you get minus 5. Then the factors are a minus 2 and then a minus 3 divided by a minus 2. Here 1 a minus 2, 1 a minus 2 is cancelled. Then the remaining terms of the LCM, the LCM is equal to a plus 6, a minus 2 and then a minus 3 is the LCM of the given term. Next we see the exercise number 3.1, question number 3. Here we want to find the GCD of the each pair of the polynomial. The last lesson we have find out the LCM, right? Here we want to find out the GCD of the polynomial. The given polynomial is 12 into x square x power 4 minus x cube and then 8 into x power 4 minus 3x square plus 2x square whose LCM is given. See, when two polynomial and whose LCM is given, we want to find the GCD, which we have the formula that is LCM into GCD is equal to, let me take it as the one of the polynomial f of x and another polynomial is g of x. Here we want to find out one of the polynomial we take as f of x, another polynomial we take as g of x. Here we want to find the GCD, LCM is given. So we want to find the GCD, means we have to divide the term. So GCD is equal to, what is the formula? GCD is equal to f of x into g of x divided by LCM. Now we have to find out the given variables, given expression. Let me take as f of x is equal to the first equation expression is 12 into x power 4 minus x cube, right? Here, see x cube is the common term. Let us take the x cube as a common outside. So f of x is equal to 12x cube into, if we take x cube common outside, we get x only minus 1. This is the f of x factors also, right? Then g of x is equal to 8 into x power 4. X power 4 minus 3x square plus 2x square. See, in this term, the least number is x square. So the x square will be taken out commonly. So here we have x square into, if we take x square common outside, we get x square minus 3, x square is taken out. Here we have x cube. I think here we have x cube. Sorry, in the question we have my mistake. So here we have x cube. In x square will be taken out commonly, means we have 3x. X square is taken out commonly, means we have 2. Now it is in the quadratic polynomial, so we can easily factorize the term. When we multiply, we need 2. When we add, we get minus 3. The simple factorization, minus 2 minus 1. Then the factors are 8x square into x minus 2 and then x minus 1 is the factors. Next, the LCM is given. The LCM is equal to, the given term is 24 x cube into x minus 1 into x minus 2. Now we have find out what is f of x, g of x and the LCM. Now substitute in this formula. Therefore GCD is equal to, in the place of f of x, I am going to substitute 12 x cube into x minus 1 into g of x is 8x square into x minus 2 x minus 1. Divided by the LCM is 24 x cube x minus 1 into x minus 2. Now we reduce the terms. See, here we have x minus 2, x minus 2. Here we have x minus 1, x minus 1. And then x cube. Right? Here 12 ones are, 12 twos are. And again 2 ones are, 2 fours are. So all the terms are reduced. There is no term to reduce again. So then the remaining terms are, here we have 4x square and then x minus 1. Therefore the GCD of the given polynomial is 4x square and then x minus 1 is the only term. So the GCD is 4x square into x minus 1. Thank you students. Class 10. Exercise number 3.4 in algebra. Reduce each of the following rational expression to its lowest form. We have to reduce the given expression to the lowest form. Let's see the third one number in first question. 9x square plus 81x plus x divided by x cube plus 8x square minus 9x. So the given term is 9x square plus 81x divided by x cube plus 8x square minus 9x is equal to, here the multiple of 9 is the number, right? So 9 will be taken out commonly, and x also the common term, so we take it as 9x commonly outside. Here, if you take 9 and x will be taken out commonly, means remainder we have only x. Here 9 9s are 81, so only 9 and the x is taken out commonly. See the denominator, here we have the x as the common term. In all term we have the x, so x will be taken out commonly. So we have x square plus 8x minus 9 is the term. Now in numerator also x and denominator also we have x, so both the terms we have cancelled. Then the remaining terms 9 into x plus 9 divided by, see it is a quadratic equation, so quadratic polynomial, so easily we can factorize the term. When we multiply we need minus 10, when we add we need 8. So whatever the possibilities means 9 ones are 9. Here we have positive value, so highest value put plus and least value put the minus symbol. Plus into minus minus, 9 ones are 9. If we subtract this we get 8. Then the factors are x plus 9 and then x minus 1. In numerator we have x plus 9 and denominator also we have x plus 9, so both cancel. So the remaining term has 9 divided by x minus 1 is the lowest form of the given expression. Further it can be factorized or cancelled, right? Next we see the Roman number 4. See the Roman number 4 is given as p square minus 3p minus 40 divided by 2p cube minus 24p square plus 64p. Write it again, 3p minus 40 divided by so, in the numerator term, here we have the quadratic polynomial, so easily we can factorize the term. When we factorize, when we multiply, we need minus 40, when we add, we need minus 3. The factors of 40 are 8 5s are 40, right? 5 8s are 40, and then 10 4s are 2 20s are, right? These are the factors. So, here the suitable factors is 8 5s are 40. See, here we have that minus symbol, so put the highest value as negative. So minus into plus minus, 8 5s are 40, and then when we add this we get minus 3. Then the factors are 8 and 5, so p minus 8 and then p plus 5. P minus 8 and p plus 5 are the factors. And then in the denominator we have p as the common term, and the terms are multiplied by 2, so 2p will be taken out commonly. Here we can take 2 and the p commonly outside, we get p square. Here it is a multiple of 2, so 2 will be taken out means 12, and then p is taken out commonly means we get p only. 64p divided by 2 means we get 32, p is taken out commonly, right? Now the denominator will have to factorize p minus 8 numerator, p plus 5 divided by 2p, and then if you factorize this term, then we multiply, we get 32, then we add, we get minus 12. Then the factors, we have all factors in the 32, right? 32 ones are 62 are 4 4s are, these are the factors. Here we have 12, right? 8 4s are 32. Their factors are 8 and 4. If you add the term, we get 12, right? And then here we have the minus symbol, and here we have the plus symbol. So both, if you put minus symbol, we get minus 12. So minus into minus plus, 8 4s are 32, and if we add, we get minus 12. Then the factors are p minus 8 and p minus 4. See, numerator also p minus 8 and denominator also p minus 8, both are cancelled. The remaining terms, there is no terms to cancel away, so p plus 5 divided by 2p into p minus 4 is the lowest form of the given expression. Thank you, students. Class 10, Algebra Ex number 3.4, question number 2. find the excluded value if any of the following expression. See the two expressions given. So the excluded value means we want to omit or accept that value, that is the excluded value. Here, especially we are going through the denominator terms. In the denominator, whatever the value is appear, if the denominators become 0 means any number is divided by 0, we have undefined value, right? So that particular which number you apply that in the denominator, it becomes 0 means that particular value is the excluded value. Let's see the sum. Solution can be taken as the third Roman number. First, x square plus 6x plus 8 divided by x square plus x minus 2. See, both the numerator and denominator is the quadratic expression. You can easily factorize the term. If you factorize the 8, then it's 6. When you multiply, we get 8. If you add, we get 6. The simple factorization 4 2s are 4 2s are 8. If you add, we get 6. Then the factors are x plus 4 is the one of the factor, x plus 2 is the another factor, divided by. For the denominator terms, see here we have minus 2 and then 1. If you multiply, we get minus 2. If you add, we get the value 1. Then simple factorization 2 ones are the factors. Here we have positive value 2, the highest value is plus, and then the least value is minus. Plus into minus minus, 2 ones are 2. If you add this, we get 1. Then the other factors are x plus 2 and then x minus 1. Now see, in both the numerator and denominator, we have x plus 2, so cancel the two terms. So the remaining term is x plus 4 divided by x minus 1. Now we want to find out what is the excluded value, especially in the denominator terms only we have to choose. When x minus 1 is equal to 0, then x is equal to 1. In the place of x, if you apply the value 1, we get 0. 1 minus 1 is 0, right? So any number is divided by, any number x plus 4 is divided by 0 is undefined. So, if you put the value 1, it becomes undefined means that is the excluded value. That number you should avoid or omit. So, therefore, the excluded value is value of x is 1. So, the excluded value of x in this term is 1 is the excluded value. Next, we see the Roman number 4. Next, see that Roman number 4, it is given as x cubed minus 27, x cubed minus 27 or 4 Roman number divided by the denominator term is x cubed plus x square minus 6x is given. Especially in the numerator terms, we can see or identify one formula in this term, that is a cube minus b cube formula. Here, this term is calculated in the form of x cube minus 27 calculated in the form of 3 cube. 3 cube is nothing but 27. 37 and 3 are 27. And the denominator term, see each and every term it contains x variable. So x will be taken out commonly. If you take x as commonly outside, we get x square plus x minus 6. For the numerator term, we have the formula that is a cube minus b cube is equal to a minus b equal to a square plus ab plus b square. That is the formula. So it is in the term. So in the place of a is equal to x and then b is equal to 3. Now we are going to replace the values. So a minus b, that is x minus 3, and then here we have x square and then a into b, 3x plus b square. 3 square is nothing but 9. Otherwise we can write in form 3 square also, divided by here we have x. So this term is the quadratic expression. So easily we can factorize the term. When we factorize, if you multiply, we get minus 6. If you add, we get 1. Here we have only 1x. So the factors of 6 are 6 ones are 6, 2 3s are 6. This is the possibilities. So in this term, suitable is 2 3s are, right? 2 3s are 6. See, here we have plus symbol, so the highest value must be plus, the least value should be minus. Minus into plus, minus 2 3s are 6. If you add this, you get 1. Then the factors are x minus 2 and then x plus 3. Now compare with the numerator and denominator. There is no term to reduce, right? So now take the denominator terms. When here we have 3 terms, x minus 2, x minus 3. When x is equal to 0. If you put x is equal to 0, the whole term becomes 0, right? So any number is divided by 0, it is undefinable. So we want to omit the value of 0, that is the excluded value, one of the excluded value. Now next we have the x minus 2. X minus 2 is equal to 0, right? Then x is equal to, we get 2. If you take minus 2 conversion, we get 2. If you put in the place of x is equal to 2, 2 minus 2 is equal to 0. 0 into any number is 0. So the whole denominator becomes 0. So it is also excluded value. Finally, x plus 3 is equal to 0. I take this 3 to another side. We get x is equal to minus 3. So in the place of x, if you put minus 3 plus 3 becomes 0. So 0 into any number is 0. So the denominator becomes 0 means any number divided by 0 is undefinable. So we want to exclude 0, 2 and minus 3. These are the excluded value. Therefore the excluded value is value of x is, one of the value is 0, another value is 2, another value is minus 3. If you excluded this value, other than this value, if you apply any value of x, we get some values. So we want to omit this value, is the excluded value of x. Thank you, students.